There we go. Okay. Hi, hello, Solar Loon here. I'm an independent game developer, the creator of Master Plan and Tetra 3D. Yeah, hi, how's it going? It's been a little while, a couple days since the last stream, and so I thought it would be good to pick it up where we left off with Tetra 3D and do some stuff. It's gonna be cool. It's gonna be fun. Um, Between then and now, I managed to make a pretty good amount of progress. Let me see if I can kind of show what I have so far. And apologies because this stream's going to be a little bit faster, a little bit shorter than normal because I don't have a lot of time today. But um, okay, so yeah, I've made some progress. And thinking about it now, that's right. I might revamp this. Yeah, I probably will actually. But basically, something that I added was this little panel where you can basically add and remove subdivision levels, automatic subdivision levels for the scene. So basically, things that are tagged as being automatically subdivided, you can just set a global setting here to basically say like, oh, to what level should it be subdivided, which works pretty well. Works pretty solidly. But I'm gonna make some changes here, and yeah, this is like currently it's global, but I'm gonna change it right now to be scene based, so that you could have different scenes with different subdivision levels depending on mesh density. So you could be like, okay, well, this is a massive open world scene. Maybe that is subdivided differently from a different scene that maybe is indoors or something like that. Um, let's get some music going. That should be roughly about good enough. Let me go ahead and pop on. Well, actually, I didn't need to close Blender now that I think about it. Let me reopen it. There we go. Oh wait, yeah, I do need to close Blender. All right, so let's head over to Tetra 3D, the add-on. Yeah, so currently I'm doing this by means of a timer, so that different timers have different levels of, like basically, that's how I'm kind of like copying values across to different scenes globally, because Blender doesn't really have a global place to store data for add-ons for whatever reason, like per blend file, which is odd, but yeah, I was doing this basically by means of a timer, but I don't need to do that anymore. Auto sub. Yeah, so this is fine. Everything should be about the same. It's just about where it gets loaded in. Yo. Locutus? Hello, welcome to the stream. Excuse me. Okay. So that should basically do it. There we go. Let's see. Cool. All right, so let's see if this works. Oh, whoops. I always forget about that. Sorry. Okay, so this is the scene. It's all subdivided. Let's go ahead and test this out. Let's just do it like this. Let's see. Oh yeah, I shouldn't be here in render. I should be in scene. Yeah. Auto subdivision levels. There we go. Okay. This would be the scene PT. Here we go. We probably want to put this somewhere. Put it here, I guess. Game props. Oh, this is camera. Whoops. Cool. All right, so that should roughly do it. Yeah, I think that should roughly do it. I guess I can do it like this to make it a little easier to read. Pull Blender back up. Okay, so game properties is in this little box. That's something else that I'm gonna do that for the object properties too. Let me split this. No, split this. Yeah, put that there. Expand game props. Expand object props. All right. Okay, and so all of this goes in here. Cool. Got to actually implement this here. Okay. Yeah, I think that should be good. No, it's not. Let's see. Spin this object. Oh, this should be box. My bad. There we go. Yeah. So this is just giving the ability to collapse stuff. So yeah, this previously this was like just different sections. I mean, like they were just in this one panel. Now I have them in little boxes you can expand and unexpand, which is very nice. Very good for legibility. So you can be like, okay, just focus on the object properties section. This could be a box. This should be a box, yeah. Auto match. I see what I'm doing wrong. Let's see some box. Because the physics stuff is yeah, this should be this should be in the base box. Do we want to put this in its own box? Seems logical. Yeah. Yeah, this should be out. Uh, here, I guess. Okay, base of... Okay, I think I might have it working. Let's see. Yeah, beautiful. Okay, not bad. Let's see. Collection object properties row. That's not row. All right, I think that should roughly do it. Q. So these are the properties. You can override it. And then there's another one. Why is it 2 boxes though? Collection object properties. This is why. Okay. Let's just do that and then do box that row. Let's try that. Okay. That's better, yeah. So each of these has a thing. And you can override one. Cool. Cool. Yeah. All right, it's pretty good. Very clean, very clean. Oh, it eats game properties up too. Is it always like that? It is, okay. Spend game props. It's a different box, so why is it collapse? Hmm. Oh, is collection. Ah, okay. There we go. Yeah, it should be in there. Cool. Okay. So that seems to be working, which is cool. That's very nice. And this is still here. We have game properties here. We can expand or contract them, and we have division levels there. Each scene has its own set of subdivision levels. Excellent. Okay. Okay. Cool. All right, that's a good start. That's a good start. Right, let's test this out. There we go. Beautiful. So you see it subdividing only the triangles that are nearby. And we're also, interestingly, I fixed it so that it's possible to do, like, just... Beautiful. Just, like to have breaks, basically. Let me see if I go over here. To just specify a subdivision level of, for example, 2 or 3 or 4 or whatever in close range, and then, like, you know, you can have a gap. Previously, there had to be, like, subdivision levels all the way through, but that's not necessarily the case anymore. Very nice. Cool. Okay, so this is working. Now, something I figured out, I just was thinking about, is... That was an accident, actually. I fat fingered. But something I realized is when we're transforming these triangles, yeah, this is the original triangle, right? As an example, we can actually avoid, like, doing a lot of work for these triangles, because we already know if this triangle gets transformed, then its subdivided triangles will also lie within the same space. So we're fine to just basically act like they we're fine to just assume that they exist, essentially. So we can do this. We can basically go to model, where we go to process the triangles. When we process a triangle that is an owner of a set of subdivided triangles, we can work with it. We can work with this, basically. So there's a couple things we can do. One is we can say if your triangle is a real triangle, then it's visible all the time, essentially. But if it's not, then we default it to be false. Like so. Because we're doing this only for the triangles that are, yeah, the non-subdivided triangles. So let's see. Okay, so okay. When we get here, where we actually do this stuff, once we get here, we don't actually need to add the triangle to the render list, essentially. We can say if try.id is not equal to subdivided triangle ID, and so it's not subdivided, a subdivided triangle, and it so that might be, yeah, we'll leave this the way it is. We'll leave this the way it is, actually. Okay. Okay. Right. Because this loops through, yeah, the triangle and then the subdivided levels, triangles of the base triangle. Okay. All right, and then okay. Okay, so if a triangle has no subdivision parent, i.e. it's a base triangle, or it does have one and it would actually, yeah, if it has no parent, then we basically check to see if the triangle would render. But if it does have one, then basically we just say if try.subdivision parent dot would render. Turn. Okay, so then this runs. These languages sub. Okay, this might work. Let's see. I feel like it. Yeah, it's not. It's not gonna. Let's see. Okay. Not visible to return. Try to ID is a subdivided triangle ID and not tried at visible. Okay. T. I see. Make this. Let me switch music. Why is wood render false? Oh, because we're immediately... Yeah, we're setting it to be false. That's true. Yeah. If the parent is not equal to nil... Oh, it's because the triangle isn't visible. Okay. If you're if you're... Oh, well... Yeah, I guess, or... That's probably more so what I'm looking for. Your parent exists, and they're not rendering, or you're not supposed to render. Okay. Cool. So the idea here is that this is more performant because we... No way. 1 mil... That much of a difference? No way. Hold up, hold up, hold up. Did I cook? Did I just cook right here? Okay, I think I cooked. I think I cooked. I think this is actually working really well. We'll see in a couple seconds. I can compare it. Like, I can just comment this out and comment. Yeah. Just cut this out. And then that's about it. I think. Let's see. No. Hmm, 1 millisecond. Let's make this more... Yeah, let's make this a bigger, a more obvious deal. Okay, so from here, we're rendering, without the characters, 5,000 or so triangles, 3 milliseconds or so. So now, if this is working, then when I do this... I think it's a little faster. On the border of 3 to 2.9 or so. Okay, it's a little faster. Went from like 3.1, 3.2 down to about on the border of 3. All right, that's pretty fast. That's I mean, you know, nice little improvement. I mean, at its core, what I just did was essentially we have a triangle, right? We subdivide it. If we are transforming a triangle, like rather than transforming the subdivided triangles of a base triangle, we can transform the base triangle and then just presume that the subdivided triangles are visible. So we don't have to do normal checking like backface culling. We don't have to do checking to see if it's off screen. We don't have to do checking to see if it's behind or too, you know, behind the screen or too far forward. We already know that the triangle is basically visible. So we don't have to do any of that stuff, more or less. We probably still need to do this, actually, the near and far plane check. That probably would still be a good idea. If it's off screen or if it's, yeah, if the normals are tweaked, I guess that's a good idea. Transform vertex positions. Right, because we have the Z portion. Well, we probably don't have to. Yeah, maybe we can clip this part out. Well, no. We need to know that we could clip out this part. Yeah. Just avoiding. Just to avoid checking if it's off screen and checking for backface calling. That's kind of important. Yeah, it's about on the same level. Render. Transformed vertex positions. Yeah, I mean, I feel like maybe it doesn't give us enough to justify the complication in code. Like doing it, yeah, looking at it now, best case scenario, we're getting a little bit. Just a tiny bit. It's not even a 10% gain. It's like a 1% gain. Like an additional point. No, it's not 1%. Maybe 10%, maybe 4 or 5%. That's not bad, I guess. 3 milliseconds. Okay, let's see. Okay, so 5371 or yeah, I guess 2448 is probably more accurate. 2448. These guys are making it more complicated, I think. But anyway. Yeah, just on the cusp of 3 milliseconds. Well, it does kind of go up a little higher, up to like 3.3 sometimes, 3.2. I guess that's something. That's, yeah, that's that warrants the concept, I think. All right, so let me walk through this logic real quick. Okay, if you're a subdivided triangle, then if your parent isn't rendering, or if you're not visible, then don't render. And then if you are not a subdivided triangle, and your parent would render, or you are visible, then this runs. And then if you're the parent, okay, is equal to nil. Then we would say it would render, and then if the triangle isn't supposed to be visible, then we'd make it disappear. I guess there's no way that this would get here, huh? Subdivision parent would render, that's up here. Yeah. Okay. So let's check this out. Back the way that it generally should be. Very cool. Okay. All right, that's pretty good, pretty good. As we get closer, it gets subdivided. So now I want to mess around a little bit with the bias with which the triangles are determined whether it should be subdivided or not. Currently, it's the distance to the triangle's center. Let's see if we can do something about that. This. So we could probably make this faster by not calculating this here. Yeah. Yeah, and then we can say... Yeah. Actually, that's fine the way it is. This could be exported, that's fine. I think. And instead, we want to probably... You know what? This is fine. We'll just do it like this. Distance squared. There. And then we can go to GLTF and say distance squared is... Oh, what's going on? Cool. All right, so that helps us out a little bit. We don't need to perform the calculation right there in the triangle. We can take that out. And then, yeah. There we go. Cool, cool. So yeah, now distance. So instead of it being the center, you could do this a couple of different ways. We can use, instead of the distance to the center of the triangle, we can use the distance to either the closest vertex, or we can use the distance to the closest point on the triangle. That's the most accurate, but it's going to be the slowest. So let's check it out to see what it looks like. Closest point on the triangle, vertex. A would be positions. Oh, point. Camera pose. Okay, let's see how this works. Yeah, you see how this is more accurate. You can already see it subdivides both triangles basically at the exact same time, because the distance to the closest point on the triangles is right here rather than the centers, which is spread across. So like, if you compare them, well, it's the same in terms of the time in which it does it, but like if I'm facing, well, that isn't too much different. What is it? Let me see. Probably would be most visible. Nah, see, yeah. Both triangles subdivide at the same time because they are essentially equidistant from the camera. Whereas this other solution, it does one way before the other because we're closer to this triangle center. So it goes 1, 2, 1, 2, versus both at the same time, which is more accurate. Yeah, see, like a single wall. But it's more, it takes more time. You can see that the frame time is higher. It's averaging 1.11, 1.20 compared to like the 1 millisecond flat that we had. Yeah. So that's not great, but at the same time, we probably do need to do this because otherwise it's just not going to be good. Like one triangle is going to if you have a big face, one triangle is going to subdivide much faster than the other one. We can compare this and test it with our platformer. Yeah, okay, we're using the new system. Oh, I have to re-export. Uh, well, map is map is empty. Hmm. This is odd. Let's see. So it's a map here, but it's empty. Why is it empty? Yeah. No, we don't need this anymore. Brands. Let's see. Auto subdivision levels. Well, it must exist. How is it working with the other one then? I think it's because it's if you leave them both to default, then there's nothing here. That stinks. Let's see if I make it slightly different. Distance is there, but not a subdivision level. I see. That stinks. So let me think. How do I want to do this? If the values are default, then Blender doesn't export them. Okay, well, that's not ideal. Let me see if I can do about that. Blender API defaults not exported. ELTF defaults not exported. Okay. Let me check something. Okay, I don't think that there's any way to do what I want to do. I think just it's going to do that. So I'm going to have to make the default values just values you wouldn't want. Because there's not really, well, I guess the presence of the thing here lets you know that there's an entry for it, and then you can just get the default. Oops. Yeah, I guess that's fine. Default. Get our default. I need to consolidate this. I guess they're just floats, huh? I want it to be distance, and then we want to get subdivision level. With the default being 1. The default being 40. Oh, I see. That's what we have data. That's what data was for. Oops. Should be data. That should be data. There we go. Okay, let's try that. Better. Okay. Cool. Right. Okay, I was like, what am I doing? What's the... Okay, I think it's working. Let me see. Let's make the distance shorter. Oh, it's not marked, that's why. No, it should be marked, right? Yeah, it is. Let's see. Yeah, okay, that's right. It doesn't seem like it's actually doing anything. Let's see. So subdivision levels is set. Let's look at oh well, let's go to here. Maybe let's see. 102. Right. Yeah, okay, that's actually correct. Right? It's 102, yeah? Yeah, 102, okay. Because it's 10 times 10, it's 10 squared. So, okay, that's right. So now let's go over here. Okay, subdivide is being called. Okay, that's working there. It's working here, but why doesn't it look subdivided? Oh, that's right. I forgot. This thing doesn't. It's not. Okay, yeah. Let me see something real quick. How am I doing this light volume? Okay, well, it's not here. Wireframe. All right. I guess I must be doing yeah, this is what I'm doing. I don't want to do that, probably. I mean, yeah, that's fine, I guess, but yeah, draw wireframe. Let's try that. There we go. There we go. That's what we're looking for. Very cool. Okay, so let's go back now to something like 40, whoops, 40 and 1 level of subdivision and see how that shapes up. Okay, so this area is subdivided, but not the area outside of there. You can see the walls subdividing on the other side of the map over there. Okay. Oops. 40 is probably kind of far, actually. And the ground is stretching like crazy. Yeah, we might need more. Yeah, 40 is kind of far actually. Okay, so we know it's working. So let's go ahead and make it 2 and 20. That's probably fine. So all of this is, yeah, there we go. Yeah, you can see it change when I get close. Okay. Frame time's not too shabby. Ground's better, but I definitely still need to add some edge loops there. Didn't solve that, but it does help. Okay, okay. All right, so yeah, this doesn't fix everything. Like I still need to add edge loops, but it does work. That's the primary thing. It does work. Okay, that's good. I'm happy with that. Very cool. Okay. Now, what's up with that wall? I forgot. What's the deal with it? Why can you go through it? I don't remember. Like I can't go through any of the other walls. What was the problem with that one? It's too big? Was that what the issue was? Yeah, I think it might be too big. Okay, so I can walk into this side. But here... Yeah, right here it kind of fades. The solidity fades. Like I want to see like... Dang. I'm trying to see exactly where the solidity is. I think the issue is like if it's a wall that's not near vertices, it's kind of a problem. I think like if it's not near an edge, it kind of falls apart. I think I feel like that's the issue, because this works pretty well. That's fine, but here it's kind of a problem. So let's test that, because I want to see if I'm on the right track. Let's say I add just a single edge loop right there toward the middle. There we go. Yeah, that's a lot better. So I already know, I don't know what the problem is, but you know, that's telling me a lot that I can add an edge loop and like instantly solve the problem. So I just need to do some testing, some more testing with larger, oh, look at that map in the distance, with some larger face sizes for walls and things. But overall, this is really good. This is 1 and some change milliseconds render time, and we're trucking along. This is shaping up pretty well. Maybe I can even make it better if I were to basically combine this with like some kind of minimum size threshold, or basically if something is too small, we don't subdivide it. Like this wall here probably doesn't need to be subdivided because it's pretty small to begin with. Like some things like this ground texture could really stand to be subdivided more, and some things like or the wall, that big wall I was looking at previously, but other things aren't, you know, like this doesn't need to be subdivided. So I might combine that, put that in there too. Let's see. Okay, so yeah, so maybe a minimum size would kind of go crazy here. Because then we could also kind of like say, for example, you don't need to subdivide it if it's not, if the triangle isn't big enough. And I think that that's important. Like these walls here don't need to be subdivided really. They're rather yeah, rather kind of small to begin with. Same thing for this like this entire room is kind of like fine the way it is. So I could either segment it out into its own mesh, or I could just add a minimum size, which I think would be cool. So let me do that. Okay, auto subdivide level. Okay. So yeah, let's roll with this. So now if we go to mesh, subdivision level. Okay, so here we go. So we want to know essentially if if this and max span is greater than or equal to L dot minimum triangle size. All right, let's go with that. Cool. So looking back at this, we might, for example, want to not transform maybe like this hallway, these hallway triangles right here. Actually add a button to turn it on and off. How would I do that? That's on the mesh. Is that on the mesh? I think it is, right? Yeah. Is it on the mesh? Yes, okay. All right, so then we can just go here and do this. Whoops. And then we don't need this anymore. That size. Okay, so let's try this again. Okay, so I am toggling it, but for some reason it's not actually. Oh, I see. glad I tested this. Okay, so okay. Okay, so I think it's drawing both. I guess we just do this. There we go. Cool. So now the triangle's auto subdivision does not have to be on. Yeah, okay, cool. So now we can say, okay, like these triangles here do not need to be subdivided, probably. So let's see if we can enable that feature. Yeah, okay, so we have minimum triangle size. So let's try this out. Let's go over here to game, or rather light volume. Oh, I need to add a thing for that. I'm running out of time. Unfortunately, I'll have to stop it here because I'm running low on time as it is. But thank you very much for watching. I'm going to add this new feature, minimum triangle size. I'm going to, there's so much to do. I have to do that collision check stuff. I've got to, I wanted to look back into using hacks instead of TypeScript for my game because that gives you a little bit more, well, it gives you just more options, more like dynamism, I guess you could say, in the language. You can do more stuff like meta stuff, a little bit more of a developed language, I guess you could say, rather than trying to stick so closely to TypeScript. But anyway, yeah, it's this is really shaping up. It's really working out well, I think. So yeah, thank you very much for watching. I've been SolarLoon. I'll catch you guys on the flip side next time. That's going to be Monday at probably 12 p.m. Thank you very much, and I'll catch you guys later. Peace.